Hello, in this lecture we'll find out the area of trapezoid ABCD. So in the drawing we have a circle that is inscribed by this trapezoid ABCD. You know that side AB of trapezoid ABCD equals to x, side BC equals to 7 over x. This is angle BAD, that is a right angle. This is angle ADC, that is also equals to 90 degrees in its size. Again, our mission is to find out the area of this trapezoid ABCD. So, first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. So here we have quadrilateral ABCD, and we know that side DC is equal to A is parallel to side AB is equal to B. Again, trapezoid is a quadrilateral with one pair of parallel sides. Here we have quadrilateral ABCD, and because of the fact that side DC is parallel to side AB, this quadrilateral ABCD is defined as a trapezoid. So what is the area of this trapezoid ABCD? The area of trapezoid ABCD, here the parallel sides, that is to say DC is equal to A and AB is equal to B, those two sides are defined as the bases of this trapezoid ABCD. So the area of this trapezoid ABCD equals to the sum of its bases, that is to say A plus B times the height, that is edge, over 2. The height must create 90 degrees with the two bases A, B, and DC. This angle equals to 90 degrees, this angle also equals to 90 degrees, and this angle is also equals to 90 degrees in its size. Okay. Again, the area of trapezoid ABCD is equals to the sum of its bases, that's actually A plus B times the height to the base, that is h over 2. So the area of this trapezoid ABCD equals to A times B times h over 2. Okay. So in the next step we will define the point of tendency of trapezoid ABCD with this circle with letters. We will define the point of tendency of tangent AB with this circle, this point, as E. Likewise, we will define the point of tendency of tangent AD with this circle as F. We will define the point of tendency of tangent DC with this circle, this point, as G. And finally, we will define the point of tendency of tangent BC with this circle, this point, as H. So here we can implement rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common extreme point to a circle are equal. So in the drawing we have a circle, and we have also this common extreme point, point P. From this common extreme point, point P, we have two tangents to this circle. Tangent PA, that is tangent to this circle at point A, and tangent PB, that is tangent to this circle at point B. So, according to this rule 2, the lengths of those two tangents are equal to each other. That is to say, PA is equal to PB. So whenever you have, from a common extreme point, you draw two tangents to the circle, the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. We can actually implement rule 2 in our drawing. Why? Because in our drawing if we focus on this common external point A, from this common external point A, we have two tangents to this circle, tangent AE and tangent AF. And according to rule 2, they are equal to each other. That is to say, AE is equals to AF. So, if we define AE, if we define the length AE as Y, then AF must be also equal to Y because they are equal to each other. AE is equals to AF. Likewise, if we focus on this common external point B, from this common external point B, we have two tangents to this circle, tangent BE and tangent BH. And according to rule 2, they are equal to each other. So if we define the length of tangent BE as Z, then the length of this tangent BH must be also equal to Z because they are equal to each other. Again, tangent BE is equal to tangent BH, and therefore if the length of tangent BE is Z, then the length of tangent BH must be also equal to Z. Likewise, we focus on this common external point C. From this common external point C, we have two tangents to this second, tangent CH and tangent CG. And according to rule 2, they are equal to each other. That is to say, CH equals to CG. So if we define the length of tangent CH as M, then the length of this segment, the length of this tangent CG must be also equal to M because they are equal to each other. CH equals to CG. Likewise, we focus on this common external point D. From this common external point D, we have two tangents to this second, tangent DG and tangent DF. And according to rule 2, they are equal to each other. That is to say, DF equals to DG. So if we define the length of DF, tangent DF as T, then the length of this tangent DG must be also equal to T because they are equal to each other according to rule 2. So what is the value of side AB plus side DC? AB plus DC. AB equals to Y plus Z, and DC equals to T plus M. So, in conclusion, we found out that AB, side AB plus the opposite side DC, in total it is equal to Y plus Z plus T plus M. Likewise, we will add side AD to the opposite side, side BC. So what is the value of AD plus BC? AD equals to Y plus T. Here, AD equals to Y plus T. And BC equals to Z plus M. So in total we actually found out that AD plus BC equals to Y plus T plus Z plus M. Okay, so we already found out that AB plus DC equals to Y plus Z plus T plus M. So if we arrange the letters here in a different order, here we get that AB plus DC is also equals to Y plus T plus Z plus M, exactly like AD plus BC, that is also equals to Y plus T plus Z plus M. Okay, so actually found out that AB plus DC equals to y plus t plus z plus m, and AD plus BC is also equals to y plus t plus z plus m. And therefore, you can derive from it that AB plus DC is equals to AD plus BC. Okay? This is equation 1. According to equation 1, AB plus DC equals to AD plus BC. Okay? Here we will define side AD as A, AD equals to A, according to our definition, and we define side BC of this trapezoid ABCD as B. According to equation 1, we found out that AB plus DC equals to AD plus BC. So AB is A according to our definition. So we substitute AB by A plus, here we have DC. Here actually found out that AB plus BC is equals to AB plus DC. AB is X, so we substitute AB by X. Plus DC. DC is 7 over X, so substitute DC by 7 over X. Repeat again. According to what is given as the question, AB is X, and here DC, this is side DC, that's equal to 7 over X according to what is given as the question. Here AB is X, and DC is 7 over X. So in total, inside of the equation, we have X plus 7 over X, and it is equals to AD. AD, according to our definition, is A plus BC. BC is B. So actually found out that according to equation 1, X plus 7 over X equals to A plus B. Okay? In the next step, we will do a construction. That is to say, from point B, we will do perpendicular on DC. Again, from point B, we will do perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC as point S. Okay, so by doing this construction, we created here quadrilateral ABSD. This is quadrilateral ABSD that we created by this construction. So inside this quadrilateral ABSD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing angle must be equal to 90 degrees in its side. Again, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, this missing angle, this missing fourth angle must be equal to 90 degrees in its size. So therefore, inside this quadrilateral ABSD, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral ABSD with 4 right angles as a rectangle. So I write it down. This quadrilateral is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB must be equal to the opposite side DS. But AB is x, therefore DS must be also equal to x. Here, DS must be also equal to x. So I write it down here. DS is equal to x. Likewise, according to the sum rule, in the same rectangle ABSD, side AD must be equal to the opposite side BS. But AD is A according to our definition, therefore BS must be also equal to A. By doing this construction, we actually created here the right triangle, triangle BSC. We just right now found out that side BS of triangle BSC equals to A. The hypotenuse BC equals to B according to our definition. So what is the length of side SC? From the drawing it is very easy to see that side SC equals to DC minus DS. Again, DC minus DS equals to SC. Repeat again. Side SC equals to DC minus DS. So SC equals to DC, that is X, and DC equals to 7 over X, according to what is given as the question, minus DS, DS is X. So in total we found out that side SC equals to 7 over X minus X. So in the next step, I will copy this right triangle, triangle BSC in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle BSC. Side BS equals to A. The hypotenuse BC equals to B, according to our definition, and finally found out just right now that side SC equals to 7 over X minus X. So actually, this is the right triangle, triangle BSC, that the copied from the original drawing. This right triangle, triangle BSC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle, triangle BSC is BC, therefore the square of the hypotenuse is BC squared. And it must be equal to BS squared plus SC squared. So this is equation 2. according to equation 2, actually found out that BC square, BC is B, therefore BC square is B square. So B square equals to BS square. BS is A, therefore BS square is A square plus SC square. SC is 7 over x minus x, therefore SC square is 7 over x minus x square. So according to equation 2, I actually found out that B square equals to A square plus 7 over x minus x square. So here we have the algebraic identity that states that A minus B square equals to A plus B square minus 4 times AB. Okay, repeat again. A minus B square equals to A plus B square minus 4 times AB. According to this algebraic identity, we get that we have here equation 2. B square equals to A square plus we have 7 over x minus x square. According to this algebraic identity, 7 over x minus x square will be equal to 7 over x plus x square minus 4 times 7 over x times x. Okay? Repeat again, according to this algebraic identity that A minus B square equals to A plus B square minus 4 times AB, we'll get that 7 over x minus x square will be equal to 7 over x plus x square minus 4 times 7 over x times x. Here we have x in the numerator and x in the denominator, so x will get cancelled. So actually found out that according to equation 2, B square equals to A square plus 7 over x plus x square. Here x will get cancelled and we're left only with minus 4 times 7 is minus 28. Okay, this is according to equation 2, while according to equation 1, we have already found out that x plus 7 over x equals to A plus B. I wrote it down here. According to equation 1, we have already found out that x plus 7 over x equals to A plus B. Here we have x plus 7 over x in both equations. Therefore, we can substitute x plus 7 over x in this equation, equation 2, by a plus b from this equation, equation 1. We'll do it now, and we'll get that according to equation 2, b square equals to a square plus 7 over x plus x is a plus b according to equation 1. And therefore 7 over x plus x square will be equal to a plus b square minus 28. So here we have 28 to this equation, equation 2. And we get that according to this equation, equation 2, we have 28 plus b square equals to a square. Here we have a plus b square equals to a square plus b square plus 2 times a times b. So here we have b square on both sides of this equation, 2, so b square will get cancelled. After cancelled b squared, we're left only with this side of the equation. We have equation 2, we have 28, that is equals to a square plus a square is 2a square plus 2 times ab. repeat again, according to equation 2, we actually found out that 28 equals to 2a squared plus 2ab. So here we divide this equation 2 by 2. And we get that according to equation 2, a squared plus ab equals to 28 over 2 is 14. So actually, in conclusion, we found out that according to equation 2, a squared plus ab equals to 14. And we already found out that according to equation 1, x plus 7 over x equals to a plus b. So those are the two equations that we have here. In the next step, we'll find out the area of this trapezoid ABCD. Okay, so we know that the area of any trapezoid equals to the sum of its two bases times the height to the base over 2. And therefore, the area of trapezoid ABCD, the area of trapezoid ABCD will be equal to the sum of its two bases. The two bases are parallel to each other. That is to say, we know that AB is parallel to DC because those two angles are right angles. Actually, we know that quadrilateral ABSD is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. So if DS is parallel to AB, then DC also must be parallel to AB. So the two bases are AB and DC. AB equals to X, DC equals to 7 over X. So the sum of the two bases is X plus 7 over X. So it is the area of triangle ABC, the area of quadrilateral, the area of trapezoid ABCD equals to the sum of its two bases, that is x plus 7 over x, times the height to the base. The height must create 90 degrees with the two bases. Here, AD creates 90 degrees with the two bases, and therefore AD is the height to the base. And you know that AD equals to A divided by 2. Again, the area of trapezoid ABCD equals to x plus 7 over x times A over 2. But according to equation 1, x plus 7 over x equals to A plus B. Here, x plus 7 over x equals to A plus B. So we can substitute x plus 7 over x in this equation by A plus B. We do it now, we get that the area of trapezoid ABCD equals to x plus 7 over x is A plus B times A over 2. We'll open the brackets here and we get that the area of trapezoid ABCD will be equal to A times A is A squared plus AB over 2. But we have already found out that according to equation 2, A squared plus AB equals to 14. So we can substitute A squared plus AB by 14 here. We'll do it now and we get that, so A squared plus AB is 14. That is 14 over 2. So the area of trapezoid ABCD equals to 14 over 2, that is 7. So in conclusion, we actually found out that the area of trapezoid ABCD is equals to 7 square units. And again, the area of this trapezoid ABCD is equals to 7 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this trapezoid ABCD. It's given us the question that side AB equals to x, side DC equals to 7 over x. This is angle BAD, that is a right angle. This is also angle, this is angle ADC, that is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So, first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. So in the drawing we have quadrilateral ABCD, and we know that the side DC that is equal to A is parallel to side AB that is equal to B. And because of the fact that in this quadrilateral ABCD we have one pair of parallel sides, that is to say side DC is parallel to the opposite side AB, this quadrilateral with one pair of parallel sides is defined as a trapezoid. Okay, repeat again, a trapezoid is a quadrilateral with one pair of parallel sides. Here, in this quadrilateral ABCD, side DC is parallel to side AB, and therefore this quadrilateral ABCD is defined as a trapezoid. So what is the area of a trapezoid? The area of a trapezoid equals, first of all, we know that the two parallel sides, that is to say side DC that is parallel to side AB, that are defined, both of those two sides are defined as the bases of the trapezoid. So the area of trapezoid ABCD equals to the sum of its bases, that is to say DC that is A plus AB that is B, so it is A plus B, times the height that is h over 2. The height must create 90 degrees with the two bases. Here h is the height because of the fact that it creates 90 degrees with the base DC, and it creates 90 degrees with the base AB. Again, the area of this trapezoid ABCD equals to the sum of its bases, that is A plus B, times the height h over 2. Okay? So, in the first step, we actually defined the points of tangency of trapezoid ABCD with this circle with letters. We defined the point of tendency of tangent AB with this circle as E. We define the point of tendency of tangent AD with this circle as F. We define the point of tendency of tangent DC with this circle as G. And finally, we define the point of tendency of tangent BC with this circle as H. So here we can implement rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So in the drawing we have a circle, and we have here the common standpoint point P. From this common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. According to this rule 2, the lengths of those two tangents are equal to each other. That is to say, PA is equals to PB. So whenever you draw two tangents from a common standpoint to the circle, then the lengths of those two tangents must be equal to each other. In this case, PA equals to PB. We can actually implement rule 2 in our drawing. Why? Because in our drawing, if we focus on this common standpoint point A, from this common standpoint point A, we have two tangents to this circle, tangent AE and tangent AF. And according to rule 2, they are equal to each other. That is to say, AE equals to AF. So if the length AE is Y, if the length of this tangent AE is Y, then the length of tangent AF must be also equal to Y because they are equal to each other, according to rule 2. Likewise, if we focus on this current standpoint point B, from this current standpoint point B, we have two tangents to this circle, tangent BH and tangent BE. And according to rule 2, they are equal to each other. That is to say, BE is equal to BH. So if we define the length of BE as Z, then BH must be also equal to Z because they are equal to each other in their lengths. Likewise, if we focus on this current standpoint point C, from this current standpoint point C, we have two tangents to this circle, tangent CH and tangent CG. And according to rule 2, they are equal to each other. That is to say, CH equals to CG. So if we define the length CH as M, then CG must be also equal to M because of the fact that they are equal to each other according to rule 2. And finally, likewise, if we focus on this common standpoint point D, from this common standpoint point D, we have two tangents to this circle, tangent DG and tangent DF. And according to rule 2, they are equal to each other. That is to say, DG equals to DF. So if we define the length DG as T, then DF must be also equal to T because they are equal to each other according to rule 2. Okay? And in the next step, we added side AB to the opposite side DC in this trapezoid ABCD. Okay, again, we added side AB to the opposite side, side DC. So what is AB plus DC? AB is Y plus Z, and DC is T plus M. So in total, AB plus DC equals to Y plus Z plus T plus M. Repeat again. In total, AB plus DC equals to Y plus Z plus T plus M. Likewise, we added side AD to the opposite side, side BC. Again, AD plus BC. AD is Y plus T. Again, AD is Y plus T, and BC is Z plus M. BC is Z plus M. So in total, AD plus BC equals to Y plus T plus Z plus M. So here we change the orders of the letters here. Here we have this, actually it is Y plus T plus Z plus M, and here we have also Y plus T plus Z plus M. So AB plus DC equals to Y plus T plus Z plus M, and AD plus BC is also equals to Y plus T plus Z plus M. Therefore, we can conclude from those two equations that AB plus DC equals to AD plus BC. Again, AB plus DC equals to AD plus BC. Okay. AB is X and DC is X over 7. Amen. Again, AB is X and DC is 7 over X. BC is 7 over X according to what is given as the question. And it is equals to AD. AD is A according to our definition. Again, AD is A. And BC is B, according to our definition. So in total, we can find out that according to equation 1, X plus 7 over X equals to A plus B. Again, according to equation 1, found out actually that X plus 7 over X equals to A plus B. In the next step, we did a construction. That is to say, from point B, we draw perpendicular on the C. Again, from point B, we do perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. We define the touching point of the perpendicular from point B and side DC as S. By doing this construction, we created a quadrilateral ABSD. This is quadrilateral ABSD. Inside this quadrilateral ABSD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Okay? Therefore, inside quadrilateral ABSD we have 4 right angles, and we know that any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral ABSD as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB equals to the opposite side DS. But AB is X, therefore DS must be also equal to X. Likewise, according to the same rule, in the same rectangle ABSD, side AD must be equal to the opposite side BS. But AD is A, therefore BS must be also equal to A. Okay? Actually, by doing this construction, by drawing the perpendicular from point B on DC, we created the right triangle BSD. So in the right triangle BSD, side BS equals to A, the hypotenuse BC equals to B, according to our definition. So what is the length of side SC? From the drawing it is very easy to see that SC equals to DC minus DS. Again, SC equals to DC minus DS. DC, so S equals to DC. DC is 7 over X, and DS is X. So in total, SC equals to 7 over X minus X. Again, SC equals to 7 over X minus X. In the next step, I'll copy this right triangle BSC in a new page and implemented the Pythagoras theorem on this right triangle BSC. So actually, this is the right triangle BSC that I copied from the original drawing. Repeat again that in this right triangle BSC, side BS equals to A, side SC equals to 7 over X minus X, and finally the hypotenuse BC equals to B. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in the right triangle in BSC, it means that BC square equals to BS square plus SC square. Again, BC square equals to BS square plus SC square. BC is B, therefore BC square is B square, and it is equals to BS square. BS is A, therefore BS square is A square, plus SC square. SC is 7 over X minus X, therefore AC square is 7 over X minus X square. This is according to equation 2. Now we have the algebraic identity that A minus B square equals to A plus B square minus 4 times AB. If you just open the brackets here, you'll definitely see that those two sides are equal to each other. So we use this actually equation or algebraic identity in this expression 7 over X minus X square. So according to this algebraic identity, we get that 7 over X minus X square equals to 7 over X plus X square minus 4 times 7 over X times X. Okay, so according to equation 2, we actually found out that B square equals to A square plus and 7 over X minus X square, according to this algebraic identity, equals to 7 over X plus X square minus 4 times 7 over X times X. Here we have X in the numerator and X in the denominator, so X will get cancelled, and therefore we left here only with 4 times 7, that is minus 4 times 7, that is minus 28. Here I copy this expression, 7 over X plus X square, and here we have all the other things didn't change. It is B square, that is equal to A square, plus 7 over X plus X square minus 28. So here we have b squared, but according to equation 1, we have already found out that x plus 7 over x equals to a plus b. This is according to equation 1. Therefore, we can substitute x 7 over x plus x squared by a plus b squared from this equation, equation 1. Well, actually, substitute 7 over x plus x by a plus b. We actually found out that according to equation 2, b squared equals to a squared, and here 7 over x plus x is a plus b. Here we have 7 over x plus x squared, it will be equal to a plus b squared, minus 28. So here we added 28 to this equation, equation 2, and finally found out that 28 plus b squared equals to a squared plus a plus b squared. A plus b squared equals to a squared plus b squared plus 2 times ab. So we have b squared on both sides of the equation, so b squared will get cancelled, and after we cancel b squared, we left only with (28) is equals to a squared plus a squared is 2a squared plus 2ab. So in conclusion, according to equation 2, I should find out that 28 equals to 2a squared plus 2ab. Here we divided this equation 2 by 2, and finally found out that according to equation 2, a squared plus ab equals to 28 over 2 is 14. So according to equation 2, a squared plus b squared equals to 14. This is according to equation 2, while according to equation 1, we have already found out that x plus 7 over x equals to a plus b. So what is the area of trapezoid ABCD? The area of trapezoid ABCD equals to the sum of its bases. The bases are the two sides that are parallel to each other. That is to say, they are AB and DC. Why AB is parallel to DC? Because of the fact that we know that ADSB is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DS. If AB is parallel to DS, AB must be also parallel to DC, because DC is the extended, if you extend side DS, you will get DC. So if AB is parallel to DS, AB must be also parallel to DC. So the two sides that are parallel to each other in trapezoid ABCD are AB and DC. So the area of trapezoid ABCD equals to the sum of its bases, that are actually AB plus DC. AB is x, DC is x over 7, so the sum of the bases is x plus 7 over x. The sum of the bases is x plus 7 over x times the height. The height must create 90 degrees with the two bases. If side AD creates 90 degrees with the two bases, and therefore AD is the height of the base, and AD equals to A. So the edge is A divided by 2. So in conclusion, we found out that the area of trapezoid ABCD equals to x plus 7 over x times A over 2. But according to equation 1, x plus 7 over x equals to a plus b, so we can substitute x plus 7 over x here by a plus b. We did it and found out that x plus 7 over x is a plus b times a over 2. That is the area of trapezoid ABCD. Here we open the brackets and found out actually that the area of trapezoid ABCD equals to a times a, that is a squared, plus ab over 2. But according to equation 2, we already found out that a squared plus ab equals to 14. So we can substitute a squared plus ab here by 14. We did it. We actually found out that the area of trapezoid ABCD equals to a squared plus ab is 14 over 2. And 14 over 2 is 7. So in conclusion, we actually found out that the area of this trapezoid ABCD is equals to 7 square units. Okay, thank you very much.